Hello, this is Lorraine Jamison, and this is GoReact quiz number 7. So the first problem was to find y of c for this equation, this differential equation, y double prime plus 3y prime plus 2y is equal to 1 over 1 plus e to the x. And so in order to do that, I just use the m squared plus 3m plus 2, and you can just factor that out to m plus 1 times the quantity of m plus 2. And then you know that m is equal to -1 and m is equal to -2, so you can just plug that into your y of c equation. So y of c equals c1 e to the negative x plus c2 e to the negative 2x. So yeah. The next problem was to use using variation of parameter to find y of p. So in order to do this, I found y1, which is equal to e to the negative x, y1 prime is negative e to the negative x, y2 is equal to e to the negative 2x, and y2 prime is equal to negative 2e to the negative 2x. And then I found the Ronchian here, and here. So you use these three Wrongians to find u prime and u prime 1 and u prime 2. So yeah, basically you just use matrices, and you cross multiply, and then you simplify to get all of these. And then u prime is equal to w1 over w, and so you just simplify that, and you take the integral to get u. So u1 was equal to ln e to the x plus 1, and then you do the same with u2 prime, where it's w2 over w, and then once again you simplify and take the integral to get u2 is equal to ln e to the x plus 1 times times the quantity of negative e to the x, minus e to the x. And then you have your yp value, because yp is equal to u1 y1 plus u2 y2. So you just plug that in for y of p is equal to ln e to the x plus 1 times e to the negative y, because that is the y1 value, plus ln e to the x plus 1 minus e to the x times the quantity of negative 2x, because this is u2 and this is y2. And then in order to find y, you just combine those two answers to get y is equal to c1 e to the negative x plus c2 e to the negative 2x plus ln e to the x plus 1 times e to the negative x plus ln of e to the x plus 1 minus e to the x all times e to the negative 2x. Thank you.